Good morning, everybody. So we have 11 o'clock. I'm Gino Spence. I see that Dr. Sean Langan is on. So we have a partner perspective today with Solvus Global. Solvus Global is a technology innovation company focused on solving problems in the materials and manufacturing space. It's a diverse team of engineering and scientists dedicated to develop critical solutions for its customers and the world at large. Solvus has a wide range of technology expertise, including additive manufacturing, software, rare earth recovery, and more. And Sean will highlight those areas today. And they focus on building people and companies to solve the world's big problems. Dr. Sean Langan, Principal Materials Engineer at Solvus Global, will walk us through an overview of the company, talk about their capabilities, accomplishments, and their interests, as well as answer questions that many of us will have. He earned his bachelor's degree in chemistry with a minor in classical civilizations from Boston University and a Ph.D. in materials engineering from Rutgers University. Sean has a wide range of technical and business expertise, and at Solvus continues to focus on developing and commercializing technologies, building relationships and new business, and growing people. And without any further ado, I'll turn it over to Dr. Langan, who will share a screen and a presentation and walk us through. And I'll leave it up to Sean to provide any further direction if it's going to be allowing questions to chime in and through the chat, or if we want to hold those until the end. So Sean, the floor is yours.
Thank you so much, Gino. I really appreciate it. And before anything, thank you to you and NCDMM for inviting me here today. I really appreciate the invitation. Real fast before we get started, could someone allow me to share my screen? It's not letting me do that right now.
You should be good there, Sean.
Thank you so much. All right, can everybody see that right there?
Yes, sir.
So let's get started.
Yep.
As Gino said, my name is Sean Langan. I'm Principal Materials Engineer here at Solvus Global. A little bit about me. I'm from Chicago, go Bears. And Gino talked about my educational background. I've been at Solvus since late 2019. I'm now the 5th longest running employee, so I have a fairly unique perspective to be able to talk to you all about Solvus. I started developing and commercializing technologies at Solvus, and now I'm more on the biz dev and people side of things, but I still do enough engineering that I can look myself in the mirror. So let's hop right to it. I'm here today to talk to you about the work we do at Solvus. I want to cover the company and the technical work that we do at Solvus, but I want to give equal importance to how we do that kind of work. And spoiler, it's great partnerships and great people. So I'm going to hop right to it. So at Solvus, fundamentally, we build businesses that solve manufacturing challenges. We take ideas, we grow them within Solvus, and when they are mature enough, we spin them out as their own companies. It's a really great, fun business model that lets us solve a lot of problems, have our fingers in a lot of different pies, and I want to share kind of a few of them with you today. So here's a list of what we do, the various kind of technical areas we're in. This is not all encompassing. We are frequently growing into new technical areas, but this is a good kind of representation. Here on the far right, I've got our first spin-out company. This is a proper spin-out company, a separate entity from Solvus now, called Valus, and they make software tools to enhance recycling profitability. We've got Powders on Demand, which was our second spin-out company that does metal powders for additive manufacturing. Our third spin-out, which happened just at the tail end of last year, is Mammoth Metalworks, and they focus on large format casting and forging replacements. Within Solvus, some of the areas we're growing, Apex, which will be our next spin-out, is manufacturing intelligence software for additive manufacturing. We have here Prism, which is robotics for infrastructure repairs. And these two don't have names yet, but they're areas that we focus a lot in. One is mineral recovery from acid mine drainage. Think things like critical minerals, rare earths, etc. And also refractory metal alloy optimization. Think for solid rocket motors, think for hypersonics. etc. It's a fairly large kind of breadth of technologies that we do, and it's a lot of fun to work on. A very kind of brief history of the company. Solvus was started in late 2017 by Aaron Burt, Sean Kelly, and their Ph.D. advisor, Durana Pellion. The first 2 years, it really was mostly the CEO, the COO, and a bunch of interns, but we secured our first, subcontract award in, late 2018 from the Army Research Laboratory to work on cold spray, a technology I'll talk about in a little bit. I don't want to go too much into this, but our first spin out was in 2022, and that's Valis Insights. Our second spin out was in 2024, Powders on Demand, and that's when Solvus hit over 100 employees. And our latest spin out was, like I said, at the end of last year, Mammoth Metalworks. We have locations. We have 4 locations across Massachusetts covering a variety of kind of technical and business needs. This last year, we also expanded outside of Massachusetts for the first time into at Missouri Science and Technology, their new Protoplex facility, which we share with them, we share with Lockheed, and we share with Caterpillar. It's a really great space. So the first thing I want to talk today is about some of the technologies we have or are developing at Solvus. I wish I could talk about all of them in depth to y'all, but because we do so much, that would probably take 2 hours, and that's a rough thing to do to y'all around lunch. So I'm going to highlight just certain specific ones. If you have questions, there'll be plenty of time at the end, or please don't hesitate to contact me after this. I'll provide my contact details. I will talk your ear off about any of these technologies. The first technology I want to talk about is our latest spin-out, Mammoth Metalworks. Mammoth creates large format AM parts for things like casting and forging replacements, or legacy part replacements, and more. Mammoth was built to solve a problem, and that problem comes around the manufacture of large metal components. One of the difficulties is how many steps there are in the building process. You have to secure your raw material, then it's shipped to the facility that makes it. It's often then shipped to a facility for a rough machining, shipped again for heat treating, shipped again for the final machining, then shipped to the final user. And that's if you can actually get the part made at all. Right now, the casting and as I probably don't have to tell all of you, but the casting and forging supply chains in our country are in a fairly tough position. A lot of people are being no quoted things that they need, and when they are quoted, it is not uncommon to have lead times of up to 2 years or more. It's been a real problem, and Mammoth was built to solve that. We solve that by bringing all of these kind of manufacturing needs under one roof. So under one roof, we can form the part. We can do first machining, we can do heat treating, we can do finish machining, and then we can get it to our customer. This allows us to reduce lead times. It allows us to do things much faster, and it allows things to do things cheaper and pass that, those savings on to our customers. Also, because of the kind of technologies we use, we can take a lot of orders that some of the big casting and forging houses wouldn't be able to. If you have a legacy part that you need 3 of, that might not be worth it for one of the big casting or forging houses. We can do that for people. We also can do the big orders people want. I'll never say no to that. Really, the forming technologies we use are all built around additive manufacturing. The 3 biggest ones that we use are wire arc additive manufacturing, cold spray additive manufacturing, and additive friction stir. I'm not going to go too in depth into these technologies. If you have questions about them, please talk to me anytime. Happy to talk to you about it. But there is one I wanted to show, if only because it's a really cool video. This is something called additive friction stir deposition. It's built upon kind of the background in friction stir welding. And basically what you do is you push material through that nozzle, and by applying enough pressure and heat, you can cause that material to flow out, and you can stack layer on layer with it. It's nice because it is a solid state process. You don't have melting, so you avoid some of the heat affected zones and other problems that you have in melt-based processes. It's a low cost technology because the feedstock, we have a lot of feedstock is what you put in before you get your final part. And we have a lot of choices in that. We can do bar stock, we can do plate stock, or we can even do powder. It's got a really high build rate. 10 kilograms per hour is fairly easy to hit. There have been people who've been able to hit up to 100 pounds per hour. And fast build rate results in lower costs. One of the nice things about these machines is they're fully integrated with additive and subtractive. You can do both of them. And last, the nice thing about it is because you have because you're doing a thermomechanical process on this, you can get forging-like properties with it. And I noticed I have a hand up. Jim, can I answer a question for you?
Yeah, hey Sean. How are the loads in friction stir additive compared to friction stir welding? Are they much lower because you're not plunging into the material?
Uh, yeah, they can be lower. I mean, I've seen everything from 6 kilonewtons up to 20 kilonewtons of force.
Okay. So you still have to clamp it pretty well
Oh
as you're
yeah.
doing the process. Yep.
Oh, absolutely. We've taken to often putting threaded holes into our substrate and bolting it directly to the anvil.
Got it. Thank you.
No problem. Happy to help. Um, with these technologies, like I mentioned, friction stir, cold spray, and wire arc additive manufacturing, we can do a lot of different materials with them. One thing we do is we don't kind of shackle ourselves to only one manufacturer of these additive technologies. We frequently will have systems from multiple competitors because one company may do one thing well and their competitor may do something else well. I'm a big believer in square peg, square hole, and usually if someone's trying to talk to you about a silver bullet, it's because they're trying to sell you something. All of these capabilities allow us to process a lot of different materials. As you can see here, many different aluminums, copper-based materials, a lot of different steels we can do. We can do a lot of nickel superalloys, titanium materials, refractories, or metal matrix composites. This lets us, when a customer has a need, we can fill that need. And if there's a material that we haven't done yet, we have a lot of experience with very quickly building that, getting the kind of background we need and getting to the point where we can make something. I actually have a transition story about that. At Solvus, we really focus on transition. We're not an SBIR shop. We want to build, technologies and get them out the door into people's hands. And here I've got an example of this. There was a missing part that was holding up a really critical anti-drone technology demonstration for the AFRL. And the existing supply chain wasn't letting them get the part when they needed it. They needed it within 6 weeks, and they were quoted 24 months, if I recall. So to do this, they came to us and said, "Can you help us out here?" And we said, "Absolutely." The problem was it was material we'd never worked with before. But within 4 weeks, we were able to go from process optimization, that's laying down your first welds, to getting material properties and tuning material properties to ensure that they were going to be what they needed to be. And we were able to go from the CAD to the finished part. This printed part was printed in 20 hours. It was 120 pounds printed. We were able to finish and test the part. It was able to perform successfully one full step up above the pressure requirements it had. So we were able to go from the concept to the finished part to deployment in 4 weeks, and the part was successfully pressure tested to 180 psi, and when the requirement was only 120 psi. And this allowed for an on-time demonstration of the system. This is the kind of work we do fairly frequently at Mammoth. There's a lot of things I can't share here that I wish I could, but always happy to talk to people about it. The second technology and spin out I want to talk to y'all about today is Powders on Demand, which provides customized, high quality powders for additive manufacturing. Before we get into Powders on Demand, we very quickly need to talk about cold spray. Cold spray is another additive manufacturing and coating process that what it does, if you're not familiar with it, is it takes metal powders and accelerates them at supersonic velocities. And then when they hit the substrate, they bond to it. They form a metallurgical bond with it. They do this. It's a solid state process, so there's no melting. You maintain your microstructure from beforehand. There's very low heat affected zone. So there's a lot of real benefits to it. And when this, in the early days of cold spray, people were really excited about the technology. The problem was when they went to their local atomizer, they bought powder, they threw it in the system, and they didn't get the results that they were looking for. They often found nozzle clogging. That's where the powder is deposited in the nozzle. that they're being sprayed through as opposed to on the substrate where they're supposed to deposit, and poor material performance from things like inconsistent bonding and delamination, porosity, low mechanical properties, etc. This led to a lot of people not trusting the new technology despite its promising features. And those who did trust the technology often found themselves in the quote unquote bulk order paradox, that traditional suppliers demanded multi-ton minimum orders, starving researchers and locking out, smaller scale companies from being able to use this technology. Powders on Demand was born to solve this problem. Powders on Demand engineers powders specifically for cold spray and for additive manufacturing. And after we have developed the materials, we make sure it's tested. We guarantee deposit reliability. We'll even, if you buy powders from us, we'll give you the recipe for the feeds and speeds for how to deposit it and how to get the kind of material properties you need. We'll tell you what the heat treatment is if you need it. We'll do all of that for you. And this allows people to, use cold spray in a way that it hadn't been done before. And it's really grown very quickly. Last year, Powders on Demand produced and shipped 30,000 kilograms of powder. At, Powders on Demand, we do this. We have a lot of different techniques we use to modify powders to make them appropriate for cold spray, be it mechanical processes, thermochemical, thermomechanical, or chemomechanical. You make custom powders for people and make sure that it's going to have the performance that they need. I have another transition story about this one. There was a problem that, a lot of kind of naval ships are having, maintenance problems. Dry docking these vessels can cost anywhere between $100,000 and $1 million per day. Cold spray repair, though, is a really great solution for this. The repairs can be performed shipboard, reducing downtime and increasing asset readiness. And, we've developed powders specifically for repeatability in these repairs. We do an application-specific development. We start with the feedstock engineering. We move on to spray optimization, testing and characterization, and we also qualify the powders for transition. These powders are qualified to the mil spec. We have national stock numbers or NSNs on a lot of these powders to make it easier for people to apply them to their needs. And the impact of this has been really great. On the USS Essex, dry dock time was reduced by 24 days. And on the Rickover, dry dock was, our powders were used and prevented a 5-month dry dock. At the cost that I told you of $100,000 to $1 million per day, this results in really significant savings. Cost savings and really improved readiness. Next, another of our spinouts, Vallis, was created. This is our first spinout to make metal recycling more profitable by optimizing and controlling sortation quality. Scott, I have a question. What can I do for you, Scott?
Yeah, before you move on with your powder manufacturing, are you doing any kind of powder flowability testing? I know you're using it for cold spray applications only, but from the perspective of additive manufacturing, are you doing flowability testing as well with the powder that you're manufacturing?
Yeah, we do flowability testing on all of our powders, and we use some standard flowability measurements, and we do non-standard, some that we've developed in-house as well. I've got a paper on it I can send you if you want that I wrote, but we do a lot of that, yes, because it's like you said, for any AM technique, it's really important.
Yes, we may want to have a follow-up conversation. I have another project that I'm working with a company, United Protective Technologies, and they're looking at actually coating powder to provide better flowability to the powder. I don't know if that would apply to what you need within cold spray, but it's a potential for a collaboration.
And we do coated powders as well. So yeah,
you do that as well. Okay.
We do. Happy to talk to you about it.
Yes. Yeah, I'd like to have a follow-up. Thanks, Sean.
No problem. Yeah. So now I want to talk about another of our spinouts, Vallis, created to make metal scrap recycling more profitable by optimizing and controlling sortation quality. So let's get into what it does. Many of the methods that are currently used in the scrap recycling industry are outdated and inefficient. Quality assessment is done on a really limited basis. Sometimes it's just one Home Depot bucket worth of scrap tested for a 2-ton order, using pen and paper to record it. A lot of the planning and monitoring work is done on huge spreadsheets that were made years ago, and all of this is prone to error and can't change quickly as is needed in kind of the modern world. Valus has developed, modern solutions to these problems. To name a few, we've got Valus Sample over here. It's an integrated hardware-software tool to replace manual data capture. And over here we have Valus Sort. It's a digital twin that captures data across operations to deliver the right information at the right time. One of the great things it does is it provides real market data so that scraps sorters can determine what the most profitable mixture for them to be, and they can sort to that so that they can get the kind of best results for their money. I have one quick example of how Valus Sample can drive results. At a single facility, it's being used for more reliable detection of REDS content, which you can see right here. In the aluminum recycling world, REDS is copper, bronze, and brass. This is providing $1 to $2 million in additional revenue per year, and all while avoiding 50,000 data entries. And that's just for one material class. That's not looking at things like zinc or stainless steel, which you can see here as well. And the last technology that I wanted to talk to you all about hasn't spun out yet, but it's something that we're growing at Solvus and hoping to spin out very soon. This is rare earth recovery, and it's extracting valuable resources from waste streams through electrochemical methods. We've developed a really great vertically integrated technology stack at Solvus that really covers all aspects of this. On the software side, we have a material search agent and a geographic information system that allows us to find the right kind of where in the country are the best opportunities for this kind of waste extraction. It was a fairly large effort to get this software working, and it's working really well. Once we have identified the proper places, we can do acid mine drainage extraction. We can do the separation, the metallization, and the purification all at Solvus. And then it circles back around to the software at the end for, really kind of fully supply chain orchestration. Gino, I see a question from you. What can I do for you?
Yes, Sean. So where in the US is the majority of the best areas for this type of technology? Because there's a lot of acid mine drainage in this area of, Pennsylvania, West Virginia, Western Ohio, et cetera.
Yeah, it's a great question. That what you mentioned there is a really great one. Montana, the Dakotas have a lot of these. We have a really good relationship with the Berkeley pit in Montana, so we can extract from there. It's more. I wish I could tell you like the single best area, but it's more. This area might have more of this critical material. This area might have more of this rare earth, and we can kind of customize it to that.
Does the extraction happen in the surface waters or within the mine?
In the acid mine drainage, the waters coming from it, that has large implications for permitting. If you're trying to mine things, permitting as you know, can take 5 or 10 years. On Superfund sites, you don't need permitting, so you can just go right into it.
Okay, thank you.
No problem. Like I mentioned, this is something. Before I get into this, David, can I answer your question for you as well?
Yeah, on the previous slide, what are some of the materials or elements that you all are interested in, and maybe what's the technology or application pool for selecting those particular materials?
It really just comes down to what the need is. One of the great things, and I can actually talk about it here, is that this is all, we bring this to the sites, and the quote unquote tweezers that we use to pull the elements out of the waste can be hot swapped. So we can go to a site, we can, collect, one waste stream, tantalum, something that's really of interest to us, tungsten with the rising costs. We've shown that we can remove tantalum very well, and other, refractories and rare earths, but we can also transition this on the fly to critical transition metals like nickel, like cobalt, like zinc.
Got it. Thanks, Sean.
No problem. Yeah, that was a great question. Led me right into this. I don't really have anything else to say about this. this is really the end of the technical conversation I'm going to have. Does anybody have any final questions on this? If not, we can get back to it at the end. Brandon, what can I do for you?
So I guess kind of my read of what's within the bounds of your organization, you are completing the extraction.
Mhm.
You are also doing atomization. Are you doing the conversion of what comes out of the ground into ingot prior to atomization? And then, sorry, I was in by phone there for the first portion. I'm
Mhm.
also curious what types of atomization capability you have internally as well. I'm assuming gas, but that's usually a bad assumption. So yeah, if you could talk a bit about those two things, I'd appreciate it.
Yeah. So on the kind of recovery side of things, we have the abilities to separate out what we need. It then can be metallized and purified. So like you said, you get ingots. On the powder side of things, we do have atomization capabilities, but a lot of what we do is taking powders that are atomized other places or produced other places, and then modifying it so that it'll be right for cold spray or for whatever additive manufacturing technique is needed. Typically, a lot of atomized powders have a microstructure that is wrong for additive manufacturing, at least solid state additive manufacturing. So we spend a lot of time modifying that. We modify the morphology. We can and there's a lot of other kind of levers we can twist. So we do have atomization capabilities, but more of our time is spent taking existing powders, with an existing supply chain and making sure that those are right for additive manufacturing.
Can I ask a follow-up? Is that okay? So in that case, when you say you do have capability, my assumption is that means this is more like R&D scale capability, or is it full production scale atomization that you have?
So we've just got our atomization system in. It is not, the massive tower system, but we can do enough to meet, if a customer comes to us and says they need, a certain amount of this powder, we can give it to them.
Okay. And then are you able to say what kind of atomization capability that is?
Honestly, that's on the powders on demand side. It just came in. I haven't had a chance to check on it. If you
Okay,
shoot me an
okay.
email, I can get you that information though.
Yeah, I can follow up. And then on the conversion side, right? When you talk about some of those processing capabilities, are you doing thermochemical processing, or are you just doing things like electron beam furnace operation, VIM-VAR? I guess kind of what's the extent of what you have within your organization in terms of conversion, right? Once you get the ore out, or once you get the raw, ingredients out of the ground, I guess what's the breadth of your capability? Because I saw niobium, so that immediately suggests, right, you have electron beam furnaces. You're doing that and then some. I don't know if you're operating the Kroll's process. What can you talk a bit about that, just so I understand your organization better?
Yeah, absolutely. So we have most of the extraction is done electrochemically. And then once that's done, we have a lot of plasma-based, capabilities for the metallization, but we can do like what you talked about with Kroll's process as well.
Okay. All right. Now that's helpful to know. Thank you.
No problem. All right. Moving on. I wanted to talk about, what really drives this work, and that's the partnerships and the people. Nothing great. I really believe that nothing great is ever done alone, and that you need a really good team to get the work done. At Solvus, this often looks like, we have engineers from across multiple disciplines. It's not just materials engineers, it's software, it's mechanical, it's electrical, it's chemical as well. But we also focus a lot on building really great teams. We have a really great network of partnerships across the country, as you can see here, and I couldn't fit all of them in, but this spans from the national labs to a lot of universities, to a lot of industry and government as well. We have a lot of people within the government who we can call we can pick up a phone, we can get the questions answered, we can know who we need to talk to. We have the academic and industrial partners that if we don't have the capability, they can handle it. And we can use this to build up really great teams when we need to. And I just want to say, if you're not at NCDMM and you see your organization and it's not on this and you want it to be, please let me know. We love working with people. That's really what has driven a lot of the success that we've had. I wanted to highlight one of these partnerships. We have it with Baylor University. It's been a really fruitful partnership that we've had together. We've won multiple programs and congressional awards together. Solvus has hired multiple of their students post-grad. You can see one here, Dr. Ryan Kinzer. We got this picture of him yesterday up in one of the AFSD machines that we have. I've served on the Ph.D. committees for several students, helping them, grow and finish up their schooling. Because the two of us have different capabilities, different expertises, it allows us to, really have accelerated technical problem solving. For example, here you can see this is the largest lubricant-free aluminum 7050 AFSD build that's, to our knowledge, ever been built. That was for a phase 1 STTR, and we're in the middle of the phase 2 right now. It's a really, really wonderful partnership. It serves everybody involved. Everybody wins on this one, and it lets us both, do more than we would be able to do alone. We're also very good at team building. There was a call that y'all released, a year and a half, 2 years ago, NCDMM, and in 4 weeks, Solvus was able to go from putting the team together, acquiring letters of support from RTX. Oh, and the team is Solvus, RTX, Penn State, the AFRL, and Powders on Demand. We were able to acquire letters of support from RTX, Dynetics, Northrop, and PEO Soldier. We wrote the proposal. Then we won the proposal with $6 million, and the work is underway right now. The work that we're doing is on new solid rocket motors using additive manufacturing to produce them so that they can withstand higher temperatures and have kind of a greater customizability. It was really great that we were able to do this in that kind of short amount of time, and we've done that many, many times over. And while these partnerships are incredibly important, arguably more important is the people within Solvus. The most valuable resource we have by far is our people. We work very hard to make sure they can grow and be successful at Solvus, and I have a couple of quick examples of that. The first up is Emily Molstad. Emily joined Solvus in 2018 as an intern, and by 2022, she was the CEO of Valis, our first spinout. Emily works really hard. She's really good at what she does, and we made sure that we could help her grow when she needed and when we could get out of her way when she needed it too. She's doing really well. In 2024, she was named to one of Forbes 30 under 30, and her company is doing very well right now. And this isn't kind of a lone example here. I wanted to talk to you all as well a little about Nicholas Goy. He's a mechanical engineer at Solvus. He joined in 2022 as an intern through the Mass CEC program, and in 2023 was hired full-time as an engineering technician. In 2024, he'd advanced his career to become a mechanical engineer. And then in 2025, he became the project lead for the very project that had hired him as an intern a few years earlier. Nick worked very hard. He was very open to feedback, and he grew really quickly because of it. And we love Nick. He always has a smile on his face. Really down-to-earth guy, connects with people very well, does great work. These technologies that we've developed are only possible because of being able to grow people. We take that really seriously. And the kind of keys to professional growth, some of them we found is mentorship. We have some really robust mentorship opportunities within Solvus. Growth opportunities. We want people to be able to grow as much as they can, as fast as they can. At Solvus, we really believe that you don't need letters after your name to grow. We think it's just the most, the right person for the right job. Are you talented enough? Are you hardworking enough? And we really take that very seriously, as you could see in the last, couple of slides I was showing. We also allow, real ownership, both in a couple senses, both of someone's career, but also in a literal sense of the companies that we spin out. The companies we spin out are divided up a couple ways. The people who go, spin it out, keep a really large percentage of it, much larger than other companies in the space do. But also Solvus keeps some of it to fund future research needs, and the rest goes to Solvus employees. I personally own a pretty decent share of our 3 spinouts. So if they sell or go public, it'll be a really nice day for the Langan household. But we also take seriously, having really good benefits, really good time off. We at Solvus, it's not uncommon for someone to have, 4 weeks off a year or more. We want people to be well rested so that when it's time to sprint, they can. And we also take work-life balance seriously. If someone doesn't want to work, we let people kind of set their own schedules as much as reasonable. People don't have to work more than 40 hours if they don't want to. If you want to really grow fast, you can, but a lot of people at Solvus have grown very fast without having to, work crazy hours. And we really pride ourselves for that. Another key to this is really kind of self-driven career trajectories. We found that people are happier and more effective when they're the ones kind of in charge of their own careers. So say there's an engineer who starts at Solvus. If they want, they can go purely technical. They don't ever have to talk to a customer if they don't want to. They can get really good at the technologies they work on, and we're very happy with this. If they want to go into operations, they can do that too. Dr. Caitlin Waldy started as an engineer at Solvus Global, and now she's our director of operations, and she does a great job. If someone wants to get into program management, we're happy to do that. Part of solving problems which is part of an engineer's job, is to make sure that things are organized, make sure that deadlines are hit, etc. And if they want to go into business development, happy to do that as well. But one of the great things is no one's limited to just one of these kind of areas. Everybody can kind of find their own right balance of these things. For example, I'm a lot on the business development side of things. I'm a lot on the people side of things, but I still do engineering work. And we found that, happier people with agency do better. When we try, if we try to force someone into doing one thing or another thing, typically they won't do as well versus if they're doing what they want to do. So to kind of wrap everything up, at Solvus, we build businesses that solve problems. We don't do science for science's sake. We do science to solve problems. And we really focus on technology, transition, and commercialization. I did want to throw this in here, if only because this is a powder that I led development and commercialization for. And it's really great when I get to see it used to repair something or to build something. This kind of focus, this ability to transition technologies comes from really strong partnerships, academic, industrial, governmental. Our partnership with y'all at NCDMM has been really wonderful. And it's built on people inside of Solvus. One last quick plug. We'd love to work with you. If you're at NCDMM, if you're outside of NCDMM, we'd love it. Be that as a collaboration, we're always looking for additional collaborators in our technical areas. Please reach out if I can help you solve a problem. If you need our services, be it large scale AM, powder production, custom powders, software for AM, rare earth recovery, recycling, consulting, or more. Or, if you know someone who needs a job, we're always hiring. We really take seriously that people are our most valuable resource. And we're always looking for the best people to join. So I want to thank y'all for all of your, time and attention today. I really appreciate the opportunity to talk to you. If you work for NCDMM and I can help you solve a problem that you're having, please don't hesitate to reach out. And if you don't work for NCDMM and I can help you with something, again, don't hesitate to reach out. And I'm happy to answer any questions I can right now.
Thank you, Sean. Great presentation. I do have one question for you before the others chime in. Powders that you all have helped develop or develop solely, have you developed with any equipment manufacturers, whether it's on the traditional additive side or cold spray specific, that you could share with us, and what those applications might have been specific for or more generic?
Yeah, no, we develop frequently with the equipment manufacturers. We're frequently on programs with them. We consult them explicitly. Things like one powder that I led development on was our WIP W2 powder. It's a wear and impact protection powder. It came about because we were trying to reduce other kind of powders in that sphere were reliant on chrome carbide. This was developed as a tungsten carbide based component. We have an EST, we had a large multi-year ESTCP program on replacement of hard chrome coatings with cold spray powders. We worked with an equipment manufacturer on that. The results are public. I can always send anyone the report that they need to, but it was found that cold spray can meet or exceed hard chrome's surfaces without the kind of deleterious health effects that hard chroming does. So we do that very frequently, Gina.
Great, thank you. And then if somebody is interested in whether it's Mammoth or the acid mine drainage, mineral recovery, or any of the other spin outs, do they get in touch with you, or are there specific contacts or any of the spin outs that they should look to contact, or how should they go about that?
Yeah, I'm a great contact. If I can't answer the question, I can always put it to the right person. But at Solvus, my job is I have to know everything. I go where there's the biggest problem and I help solve it. So I need to know everything. So I'm a good person to come to for those kind of things.
Okay. And then lastly, do they all of the spin outs roll up underneath of Solvus, or do they standalones at this point once they spin out?
Standalone companies. Solvus does own, a certain percentage of that company, but it is a full standalone company. One of the nice things that we do though is Solvus, we have, our service agreements with them, so we can take their back of house work, that kind of thing, versus them having to hire, people specifically for that. We found that investors really like that because we can do it much more efficiently and at a fraction of the cost that it would have costed them.
Okay, great. Thanks. I'll stay quiet because I'm sure there's others that want to ask some questions. Thank you.
No problem. Anything else? I know there were a lot of questions that we talked about during the, presentation.
No other questions? Going once, twice? Okay, well, thanks again, Sean. If you could, Sean, if you can forward over the slide deck, and we can post that and share that with anyone, if you don't mind. Great discussion, great presentation. Appreciate your time today.
Thank you, everybody, and have a great day and a good weekend.
Thank
Bye
you.
now.
Bye.
Bye, Sean.
Thank you. Thanks.
Thank you.
Thanks, Sean.